Okay, so yesterday, we were looking at what is a vector component addition problem going to look like for us? How do we solve it? So, reminder of what vector component addition means. Okay, I will have two vectors which both have magnitude and direction. Okay, like the two we had in this example problem. Okay, the two we had were an 8-kilometer vector angled 30 degrees south of west. That's the black one. Right? And the 3.5-kilometer vector that's angled 50 degrees north of west. That's the red one. Okay? Now, I draw all vectors tail to head, so I draw those two vectors with their magnitude and direction. I put them tail to head, and then I'm asked to calculate the total displacement. Well, that'll be represented by the blue line, which connects my initial position with my final position, okay? Because that's what displacement is, the change in position. Okay, so now that I have that, okay, I know that all of these triangles have a horizontal, or x component, and a vertical, or y component. Right? What I need to do is find those x's and y's, those horizontal components and vertical components, and put them together. Okay? If I'm looking at the black line and the red line, okay, the horizontal part of the black triangle plus the horizontal part of the red triangle add up to the horizontal part of the blue triangle, okay, which is my total. Right? It is the same for the y components. Black y goes down while red y goes up. When I add those together, they add up to blue y. Okay? When I have those, I will have two sides of the triangle for my displacement. Since I have two sides of a triangle, then I can calculate the hypotenuse, and I can calculate the angle, which is the magnitude and direction of what the question asked for, my total displacement. Okay, everybody with me there? All right, so as far as we had gotten yesterday was we had calculated, okay, the horizontal components of the blue triangle, right? And we had done that by finding the horizontal component of the black triangle, okay? So black x was the adjacent side of that triangle, adjacent to the 30-degree angle. So we used cos of 30 times 8, and we got 6.928. Okay. Then we found the y component. It was the opposite side. So we went sine of 30 times 8, and we got 4. Okay. Did the same thing on the red triangle. X was adjacent, so we went cos of 50 times 3.5. We got this number. We went sine of 50 times 3.5, and we got the y component. Okay. And then we were adding those together. So I took black x and black y, which was 2.681, sorry, black x, sorry, and red x, sorry, which was 2.250. Okay, and I added them together, and I got 9.178. So this whole blue side, okay, the x component of the blue triangle is 9.178 kilometers west. Okay, I'm going to do the same thing with the y components. Okay, 4 kilometers south plus 2.681 kilometers north, right, will give me my total y component, which ends up being 1.319, we'll say. Kilometers, and that is, according to my diagram, which way? Which way does blue y face? Down, which is south. Okay. All right, so this fits with my triangle. It says I go west and south. That's what my triangle says. So I know then at least that I've drawn the thing right. My calculations fit with what I've drawn. Right? Now that I have the two sides of the blue triangle, I can calculate D using Pythagorean theorem. Yeah, x or a squared plus b squared equals c squared. Okay, so the displacement, the magnitude of the displacement anyway, okay, will be 9.178 squared plus 1.319 squared. Now, I'm only writing that many decimals. I'm going to use all the ones in my calculator when I actually do the calculation. We don't round off until the very end. Okay, I know it looks like that's what I'm doing, but I just don't have time to write out every single number on the board. Okay, we'll just keep them in the calculator for now. Okay, so take that one squared, and then the other one was 9.17795.64 squared. Okay, so my overall displacement is 9.27 kilometers. Okay, and now I need to find the direction. So if I go back to my diagram here, right, if I want to find theta, I know all three sides of the triangle. I could use any trig function I want to find it now. Agreed? Right? I could use sine, cos, or tan. I'm going to use tan just because I like to. Okay, so y is opposite the angle I'm finding. X is adjacent. Okay, so I'm going to go tan to the minus 1 of, sorry, theta equals tan to the minus 1 of my 1.319 over 9.178. Okay, and that will give me my angle. Okay, so again, I'm keeping all the decimals, right? I'm putting them all in there, and I'm getting 8.18 degrees. And which way is that?
South of west.
South of west, right? Because this is west, and then south of that, so south of west. Okay. All right. Now I need to go back and check how many significant digits I have in the question. Everything's how many? Two. Okay, so my answer then can only have two. All right, so my answer will be 9.3 kilometers at 8.2 degrees south of west. Now, had I drawn the triangle the other way, right, I could have also drawn it this way. Either way would be correct. Okay, it'd still have the same numbers on the sides. They would just switch being opposite or adjacent. Okay, I could also write then that this could be 92 degrees, or sorry, not 92, 82 degrees. 82 degrees west of south. Either one of those would be correct. Okay, they both have two significant digits. All right. Okay. Is it a lot of steps? It is. It's a lot of steps, but here's the thing. It's always the same steps. Okay? I draw the diagram. I find all the x's and y's using trig. I use them to get my resultants, or my, in this case, displacements, x and y. Pythagoras, trig, done. It's always the same steps. So once you learn those steps, okay, it's just a matter of speeding them up and doing them a little bit faster. Okay? All right, so let's have a look at the nuts and bolts of this. Okay, you've seen it all once. Now I'll kind of explain each step as we go here. All right, so if we're looking to resolve a vector into its components, that means finding that x and y, okay, like we did with the black line and the red line. Okay, so in this case here, okay, if I know the magnitude and direction of a vector, which I would, okay, it would be possible to find its horizontal and vertical components, okay, just like I would here. Right, so if I know what A is and I know what theta is here, I can use trig to find the vertical and horizontal parts of that triangle. Okay, everybody good with that? That's resolving a vector into its components. Okay, so that looks like this for this triangle here. All right, to find this side, which is adjacent to the angle, okay, so finding this side here, okay, I would use cos. I would go hypotenuse times the cos of theta. To get this side, which is opposite the angle, I would use A, the hypotenuse, times the sine of theta. Then I would have those two sides. Everybody okay with that? That's like what, grade 9 trigonometry. Okay, maybe grade 10. You would have also done grade 10. Okay, so if we're looking at this example here, we're going to say that the blue line there, D, is 175 meters long, and it's angled 50 degrees above the x-axis. Okay. If I want to find its x component, x is adjacent or opposite this angle? Adjacent. Okay. X isn't always adjacent. It just has been in every triangle we've done so far. Okay. possible for it to not be there. All right, so we have, okay, x being the adjacent side here, so to find it, okay, we'll use cosine. Okay, so that'll mean, okay, remember that the cos of theta equals adjacent over hypotenuse. So if I want to find the adjacent side, I multiply both sides by the hypotenuse, and that'll get me the adjacent side. Everybody okay with that manipulation? Okay, so that's what we're doing here. So for this one in particular, okay, x will equal 175 times the cos of 50 degrees. All right, and that should give us 112 meters. Okay, so if I'm punching that into my calculator, okay, it looks like this. Cos of 50 times 175. 112. Okay. To find y is the opposite side, so similar calculation, except instead of using cos, I'm going to use sine. 75 times the sine of 50 degrees, okay, which we have right here. That'll give us 134 meters. Everybody okay with how we calculate the components? Okay. Now, if we have more than one vector, like we had in the example we just looked at, okay, then I have a situation like this. So I have these two vectors, A and B. All right? A and B both have a horizontal and vertical part. Right? And when I put them tail to head, I can see that those horizontal parts add up to the total horizontal, and the vertical parts add up to the total vertical in my diagram. Okay? That's what we're doing with vector component addition. Finding these components and then adding them together to get the components of what we call our results. Okay? This is our result. And we're looking for its components so we can find it. We're going to follow on that diagram. I tried to show that on mine yesterday by moving things around on there, okay, just so that you could see them. Good with that one? Okay. So we're going to do this one together now. Okay, and I think, is this one in your notes package? I think part of it is. Okay. Let's have you write it down, okay, and we'll walk through this one as well. All right, so the diagram's already drawn. Now, that's kind of the hard part, is getting the diagram right, but let's look at how that diagram gets drawn first. Okay, so I've got vector A that has a magnitude of 145 meters. Okay, so the blue line here is 145 meters long. All right, and it's angled 70 degrees above the horizontal. Now, something I don't like about this diagram is that if I was using this angle, I would draw the triangle that way, so that the 70-degree angle was inside of the triangle I would be finding. Okay, but they didn't do it that way. Okay, they drew the triangle over here. That's fine. What's this angle? 20, right? I mean, if this is a right angle here, right, it's 90 degrees. This is 70, this must be 20. All right, so I'm just going to put 20 in here so that I can use the triangle the way they drew it. All right, the second vector, okay, is 105 meters. Okay, and it's angled 35 degrees below the horizontal. They drew the triangle well on that one because the angle is inside the triangle, which is the way it should be. Right? So we're just going to forget that this is here. Okay. So my overall displacement, which is my resultant, is line C. Okay? It goes from my initial position to my final position. All right. And it also has an x component and a y component, just like the other two. Okay. If I take blue x and green x from this other line here, okay, they're going to add up to red x. So I need to find those two lines. If I can find those two lines, I'll know the horizontal side, okay, of the resultant's triangle. Right? So that's one of the things I'm going to have to do. Okay? And the same would be true for the vertical parts. And this. Okay, so I've got blue y. Okay, if I take blue y, oh, I want all of it. Okay, you get the idea. If I take blue y over there, okay, and I add it to green y, which is negative, I'll get red y. Okay, everyone okay with that? I'm taking the components and adding them, vector component addition. All right, so the next step then is I need to find all the x's and all the y's. Okay, so in this case, blue x, opposite or adjacent to that 20-degree angle? It's opposite. All right, so I'm going to use sine to find that. Sine of 20 degrees times the hypotenuse, which was 145 meters. Okay, so calculate what that is. Okay, so blue x is 49.593 meters. Again, I'm going to keep all those decimals. I'm just not going to write them out. And I'm going to say that that's positive because that's all I was given here. Okay, it's that way to the right along the positive x-axis. Okay, then I'm going to find blue y. Blue y is the adjacent side, so I'll use cos. Okay, 136.255. Okay, so I've got those. Okay, that's also positive because it's up. Okay. Then I'll do the same thing for the yellow/green triangle over there. Okay, so green x, is it adjacent or opposite the 35-degree angle? It's adjacent, so which trig function am I using? Which one? Cos, yeah, because I have the hypotenuse and I have this angle, so I'm going to use cos. All right, so cos of 35 degrees times 105 meters. All right, so 86.011. Meters, and that's also going to be positive because it's in the same direction as blue x. All right. Green y is opposite the 35-degree angle, so sine of 35 times 105. Okay. Is 60.226. Positive or negative?
Negative.
Negative. It's in the opposite direction of blue y, and I made blue y positive. All right. So now I've found all the x's and all the y's. Now can I find red x and red y?
Yeah.
Yes. Okay. So I can find them. That's my next step. Is this going along the same steps as the first example? Yep. Drew the diagram. I just found all the x's and y's. Now I'm going to add them together to get my resultant x and y. Okay, so red x, okay, will be 49.593 plus 86.011. Right, and again, I'm going to use all of my decimal places here. Okay, so we're looking at 135.604. meters, and that'll be positive. Okay, and now I need to do the same thing with the y's. One of them's positive, one of them's negative, so I can add a negative or I can subtract. It doesn't matter which way I do that. Okay, so I'm going to have. Oh, I lost that number. Look at it again here. Minus and then I lost the other one too. Okay, no I didn't. 60.22. Okay, so I'm getting that red y is 76.030. Okay, everybody following what I've done so far? Okay, don't be afraid to stop me if you get lost. All right, now that I have those two sides of my resultant, which happens to be a displacement vector, can I find its magnitude and direction? Yeah. Yes, okay, I'm going to find its magnitude using Pythagorean theorem, because I have two sides. Okay, I'm going to go a squared plus b squared and get c. So we'll have 136.25543 squared plus our answer from the last one squared, which is the 76.03. Okay, so my total displacement's magnitude is 156.03 meters. Okay, so what we did there to get D, okay, is we took our 135.604 squared plus 76.03 squared. Okay, we added them together and we got our 156.03 meters. Okay, now we need to find theta. Okay, I'm going to use tan. I'm going to use the opposite and adjacent sides. So I'm going to go tan to the minus 1 of my opposite side, which the way I drew the triangle is 76.03 over 135. Did I type in a number wrong here, guys? I did. Nobody stopped me.
Yeah, it should be 135.
It should be 135.604. Yeah. I don't know where that number came from.
That was your original proposed value. Yeah.
Here?
Yeah.
Okay. Oh, okay. I got you. Okay. Okay, I don't have all the decimals for that one. We'll have to go with that. Okay, so we're getting 29.3 degrees. Okay, which direction is that 29.3 degrees? North. North of east. Okay, how did I determine that? Okay, well, the angle arc is touching east and going north, so it's north of east. All right, so then my final answer will have how many significant digits? 3. Okay, so my final answer will be 156 meters at 29.3 degrees north of east, or at 69.7 degrees east of north, if they drew it the other way. Okay. All right. Yes. it's a lot of steps. Yes, it's kind of tedious, okay? But this is how we add all vectors, and this is going to continue into Unit 2 when we have to add force vectors together to get the summation of forces. You may. All right, so that's how these are going to work, guys. Okay, like I said, they all work the same. We draw the picture. We find all the x's and y's. We add the x's together, add the y's together. Pythagoras, trig, delta. Okay, always the same steps. Okay, so this is just the notes on what I did there, okay? Written out like neater and slower. You have this in your notes package, so I'm kind of going to skip it because we already did it. All right, so that's finding them all. Okay. Okay, I want you guys to try 1 and 3 on this one here. This is just finding a vector component, so finding one side of the triangle or two sides of the triangle from a single vector. Okay? So they're giving you the vector here, or giving you the hypotenuse of the triangle, and asking you to find the north component. That would be the y, okay, of that triangle. So I'll give you a couple minutes on 1 and 3 there. Okay, so first step, I need to draw this vector. It's 15 kilometers at 40 degrees east of north. So here's how I draw that. Since it's measured from north, I draw myself a reference line that's north. That's going to end up being one of my two components. Okay, it's going to end up being the north component, which is what I'm going to calculate in a minute. I'm going to go 40 degrees east of that. Okay, maybe that's 40 degrees, it's close enough. Okay, and this is 15 kilometers. Okay, so there's my triangle. That's the x component, that's the y component, that's the part that points north. Okay, this is a 40-degree angle in here. All right, if I want to find that north component, what trig function am I using? Cos, yeah, it's the adjacent side. So to get y, I will go cos of 40 degrees times 15 kilometers. Okay, so I'm getting 11.5 kilometers north, okay? There's only two significant figures there, so it's actually going to round to 11 kilometers north. Okay? Everybody with me on that one? All right, how many people have done number 3? Okay, I'm going to give you a couple minutes on number 3 then. Okay, so for number 3, we've got 65 kilometers at 37 degrees east of south. Okay, so when I'm drawing this triangle, the second direction listed is always my reference direction, and it's south. So I'm going to draw a line that's south, okay, and I need to go east of south. So that means go this way, 37 degrees. Okay, so here's 37 degrees, here's 65 kilometers, right? And they want me to find out how far east, that's the x component, does it travel. So that's the opposite side. X equals the sine of 37 degrees, because sine's going to use the hypotenuse and the angle, okay, times 65. Okay, so we're getting 39 kilometers east. Okay, that's what they've got there, 39 kilometers east. Okay, is that making sense how to do that? Okay, I'm going to make one up here, and this one is going to be just like what you will see on your unit exam. Yay. Okay? It's actually going to be a little shorter than the two examples we've done thus far, because unit exam, well, time's a factor. Okay, so I make the question a little bit shorter. All right? So, I'm going to write it out. You're going to have to draw it and see how you do here. Okay? Okay, I want the total displacement of those two vectors. 10 kilometers due east, then 15 kilometers at 30 degrees north of east. Right, I'm going to give you a few minutes to draw the diagram yourself, and then I'll draw the diagram. Okay, then I'll give you a few more minutes to kind of get through the X and Y's and all of that. Let's have a look at the diagram. So your diagram should set up like this. You have a vector that is 10 kilometers due east. Then you have a vector that is 30 degrees north of east. So I'm drawing a reference line that's east. I'm going to go 30 degrees north of that. Okay, where does my result go? The line that represents the total displacement.
It's going to go from the end of the 15 kilometers to the 10.
Yeah, other way around actually. Go from the beginning of the 10 to right. So it's
end of 15.
right. I know that seems like it's the same thing, but if I drew it the way you said, my arrowhead would be here. Does that make sense?
Yeah.
Yeah. So we want to make sure we're always pointing the way we're actually going. All right. So that means that would have X and Y components that look like that. Okay, give you a few more minutes, see how you do. What's the trick here?
The trig.
No. What's different than the other ones we've done?
It's only one triangle.
Yeah, there's really only one triangle. The 10-kilometer vector only has an X component. And its X component is 10 kilometers. Right? If you're going due east, do you go north at all?
No.
No. Okay, so it doesn't have a Y component. It's not a triangle. There's a lot less trig in this question because you only have the one triangle to work on.
Yeah.
Okay, keep going. So we've got the diagram. The next part is, listening please. The next part is find all the X's and all the Y's. Well, for the blue vector, that's easy. Okay, the X component is 10 kilometers east. Okay, and the Y component is 0. Doesn't go north or south. Okay, so it doesn't have a Y. Didn't have to do any trig to get any of those. Okay, then I've got to find the X and Y's for the red triangle. All right, so red X is the adjacent side to the 30-degree angle. So we'll go cos of 30 times 15 kilometers. Okay, so that's going to be 12.990 kilometers, and that will be east. All right, and then our Y component is the opposite side. Sine of 30 times 15 is 7.5 kilometers north. Okay, everybody all right with that? All right. Can I very quickly now find green X and green Y? All right, and that's my next step. Okay, steps are always the same. All right, so green X is going to be 10 kilometers plus 12.99 kilometers, so that's going to be 22.99 kilometers east. Okay, and the Y component's even easier because it's 0 plus 7.5, so it's 7.5 kilometers north. That's the only north I go in that whole trip. Okay, now that I've got those two sides, can I find out what my total displacement, magnitude, and direction are? Yes. Okay, so same steps as before. I'm going to find the magnitude of the displacement using Pythagorean theorem. 22.99 squared plus 7.5 squared. Okay, so we got 24.2 kilometers as the magnitude of that vector. Okay, then we've got to find theta. Okay, so I'm going to find theta using tan. So tan to the minus 1 of 7.5 over 22.99. Okay. And I'm getting 18 degrees, 18.1 degrees. And which direction is that?
North.
North of east. Right. Okay, so my final answer is going to have two significant figures. So it'll be 24 kilometers at 18 degrees north of east, or it is possible that you may have drawn this final triangle this way, and that's fine if you did. You would have found this angle, right, which will be 72 degrees east of north. Either one of those would be correct. Okay. All right, is this sort of making sense?
Yeah.
That's exactly the kind of thing I'll put on the unit exam for vector addition, because it makes you do all the stuff, but it doesn't take as long as one where you have to find x's and y's for both triangles. Okay? And you'll have to do quite as much trig. So on the unit exam, I always have a vector addition question that has one vector that's either horizontal or vertical, and then one that's angled. Okay? And then you still have to go through all the steps, but it doesn't take as long. Right? So next week, okay, we're going to be doing quite a bit of vector addition stuff, but we are going to break it up with a lab. Okay? So we'll be doing a lab on constant velocity, position versus time graphs, things like that. Okay? That might even be Monday. We'll see how it goes. Okay? But that stuff will be coming up. I would suggest, guys, okay, having a look over this stuff a little bit, take 10 minutes or so on the weekend to look it over, so when you come back on Monday, it's still fresh in your mind.
I got it right out. I got it right out.
For some reason, I keep on getting 17 hours for the.